Alright, the next problem we're going to take a look at, it tells us that ABCD is a rectangle. Some of the properties of rectangle are that all of the corners are all 90 degrees. The opposite sides are congruent. Okay, the diagonals are congruent, so this whole length here and this whole length here are the same exact size. Okay. Alright, so because the diagonals are congruent, we get a bunch of isosceles triangles inside the rectangle. So what ends up happening inside the rectangle is that these angles and these angles are the same size from the isosceles triangle they're in. And they're also congruent to the ones underneath. And then we also have that these angles here that I'm highlighting in yellow are also congruent to each other. Okay, so let's take a look at some of the measurements they gave us. They told us that BC is 8.5. Well, that's one of the sides, and I know that opposite sides are congruent, so this other side, AD, or DA, whatever you want to call it, must also be 8.5, so I can fill that in. Okay, I know that AB, they did not tell me, but they did tell me that CD was 19, so therefore AB, the one across from it, must be the same. Okay, they told me that the part of the diagonal that's AE, which is from A to E, so this part of the diagonal is 10.95. Okay, that means that all the other halves of the diagonals are the same size, because the two whole diagonals are congruent and they both bisect each other. So that means all their parts have to be congruent too. So that means BE is 10.95, CE is 10.95, and DE is also 10.95. All of these parts, that, they're all the same size. Okay? Alright. Now, last it wants to know if for our side lengths or segment lengths AC. Well, AC is this whole entire diagonal. We know half of it is 10.95. The other half of it is 10.95. So let's add 10.95 and 10.95 and see what we get. We get 21.90. Or I could just say 21.9. Now, DB is the other diagonal, and the two diagonals are congruent, so it's going to be the same. Okay, I'm going to erase some of this stuff because my diagram's getting kind of crazy. And then I'll redraw anything that's important that we need. Okay, so one of the angles that it gave us was angle AEB. AEB. That's this angle right here. That's 130. Okay, now I can, if I know one angle in the rectangle, I can find all the other angles because there's a bunch of congruency here that helps me. So I know because this is an isosceles triangle that these two angles that I'm highlighting in blue are the same size, right? So if they're both the same, let's call them both x. I know that all three of the angles in this upper triangle that I'm highlighting in green, they all add up to 180. So I'm going to do x plus 130 adds up to 180. So now I get 2x plus 130 equals 180. I'll subtract, I get 2x equals 50, and then I get x equals 25. Okay, so that means that both of those angles are 25. Okay, I'm going to erase a little bit of stuff here so that I can make some more markings. Okay, so I know that one's 25, that one's 25. If I found those two, I know that this one over here and this one over here in a congruent triangle to the one I was just working with, so these are both also 25. Okay, now I can also find this angle right here that I just drew the yellow arrow to, because I know that this whole thing here is 90 degrees. So I can do 90 minus 25, and that will give me that missing angle that I just drew my yellow arrow to. Okay, and so that would end up giving me, for that one, 65 degrees. Okay, now I know that this yellow angle that I just found is the same as this one over here, so that one is 65, and then this one over here is also going to be 65, and then this one over here is also 65, because in those two triangles they're isosceles and congruent. Okay. Alright, now probably the last angle I want to find is this one here that I'm going to highlight in green. Okay, one thing I know about that one is that it's supplementary with the one next to it with 130. So I can just subtract from 130 to find it. So I get 50. So that green one's going to be 50. Now I have pretty much all the angles that I need. This one over here is the same size because it's vertical. This one over here is the same size as the one across from it because those are vertical. So now I have mostly all the angles in my rectangle. So let's just fill them in. Angle ABE, if I locate where that is, it's 25 degrees. Angle EBC, that one was 65. Angle BCE, that one was 65. Remember, you're looking at the middle letter and the two other letters that help form it to identify where it is. Okay. Angle ECD, that's this one. That was 25. Okay, angle CDE, CDE, that's right here. That one also is 25. Angle EDA, 65. Angle DAE was 65. Angle EAB, that one was 25. Okay, angle BEC, BEC was 50. CED, that was 130. And DEA, that one was also 50.